2020 A-Level Combined Mathematics Paper 1 Part B question number 16. This video is being done outside of my normal schedule with a special request to use GAN-G6c. If you yourself have such requests for videos of questions or lessons, then post them in the comments down below or in the comments of my other videos, and I will most likely check them and make similar videos to this in the future. Now moving on to the question. Since this question is quite long, I will be first discussing the first half of this question until this point, and then after discussing that, start discussing the second half of the question until the very end. Now to start with the first part of the question, the first part says, let the point A be given by the coordinates of 1, 2 and the point B be given by the coordinates of 3, 3. Now given this, we are asked to first find the equation of the straight line L that passes through the points A and B. After this, we are then asked to find the equation of the two straight lines L1 and L2 that are both passing to the point A and are also both each making an acute angle of pi by 4 radians with the line L. Now after this, we are then asked to show that the coordinates of any point on the line L can be written in the form of 1 plus 2t, 2 plus t, where t is some element of the real numbers. Now this last part here is actually talking about parametric equations. If we take the value t to be a parameter, we are asked to show that our line L can be given parametrically by the coordinates of x equals 1 plus 2t and y equals 2 plus t, where that is going to be some point on the line L. Now to start with this question, let's use the coordinates of A and B to find the line L that passes through those 2 points. So for that, what we have is this situation where we have 2 points A and B and a line L that passes through both of those points. Now as we know, the gradient of any line is equal to y2 minus y1 divided by x2 minus x1, where x2, y2 is one coordinate on the line L and x1, y1 is another coordinate on the line L. Now in this case, if we use the coordinates of 3, 3 and 1, 2, we get the substitution m equals 3 minus 2 divided by 3 minus 1, and simplifying we can see we get 1 divided by 2, and therefore the gradient of the line L is 1 over 2. Now using this, we can directly find the equation of the line L by using the formula y minus y0 equal m times x minus x0, where x0, y0 is one of the coordinates of one of the points on the line L. So in this case, I can take either 3, 3 or 1, 2, but I'm going to take 1, 2 since it looks simpler. So using 1, 2, we can see the line L would be given by y minus y0, which is 2, equals m, which is a half, times x minus x0, which is 1. So x minus 1. Now simplifying this, we can see if we take this to the other side, we get L given by 2y minus 4 equals, on the other side we have x minus 1. Now here, if I take this stuff to the other side, we can see we get L given by x minus 2y, and if you take the minus 4 to the other side, it becomes plus 4, so we get plus 4 minus 1, which is plus 3, so we get plus 3 equals 0, and therefore we have the line L, which is in the form ax plus by plus c equals 0, and with that we are done with that part of the question. Now moving on, the next part of the question says find the equation of the two straight lines L1 and L2 that both pass through the point A and each make an angle of pi by 4 with the line L. So considering what that looks like, if I copy this image and go down and paste it and try to draw the two lines that both pass through the point A and each have an angle of pi by 4 with the line L would look something like this. We'd have one line like this, another line which would probably look something like this, where these two lines both pass through the same point A that the line L passes through, and each of them have an angle of pi by 4 with the line L. So the angle here is pi by 4 and the angle here is also pi by 4, meaning the total angle here is 90 degrees. Now in this question, since they are not specified which line is the line L1 and which is the line L2, I can label them however I want. So I'm going to label, let's say, this one as line L1 and the other one as line L2. Now considering lines L1 and L2, what we need to do is to establish some kind of common identity or equation that we know is true for L1 and L2 and use that to find the equations of L1 and L2. Now, from the information that we're given here, all we know is the equation of the line L and the angle between it and the other two lines. We also know that if you have two lines like so with gradients m1 and m2, from theory, if the angle in between them is theta, then tan theta will be equal to the modulus of m1 minus m2 divided by 1 plus m1 m2. We also know that if you have another line which has gradient, let's say m3, and this angle is also theta, then applying that to just m2 and m3, you will also get the equation tan theta equals modulus of m3 minus m2 divided by 1 plus m3 m2. So if we just substitute instead of m1 and m3 just m, we will get the equation tan theta equals modulus of m minus m2 divided by 1 plus m2. Now according to this, we can see both of m1 and m3 are solutions to the general equation of tan theta equals m minus m2 divided by 1 plus m1 m2, or rather m2. From this we can see, if we just make this equation and try solving it, we should get both solutions for m, and one of them is going to be m1 and the other is going to be m3. So therefore in this case, if we just assume that one of these has gradient of m and try to solve the equation that we get from this equation right here, we will get both gradients of both L1 and L2. So therefore, if I erase this and start by substituting this equation for the specific coordinates of L1 and L3, taking, let's say, L1 and L2's common gradient to be represented by m, then we can get the equation tangent of the angle theta, which is in this case pi by 4, equals modulus of the gradient m minus the known gradient of the central value, which is in this case the gradient of the line L, which is 1/2, so minus 1/2 divided by 1 plus m times 1/2, or 1/2 m. So we get this equation right here. Now substituting, we can see on the left hand side tan of pi by 4 is 1. So we get 1 equals, on the other side we can divide this thing by taking the modulus on top and bottom separately. So we can divide it as modulus of m minus 1/2 divided by modulus of 1 plus 1/2 m. Now from this we can see we get modulus of m minus 1/2 being equal to the modulus of 1 plus 1/2 m. Now there are two cases in which this can be true. This can be true if both of these are exactly equal to each other, meaning that m minus 1/2 is exactly equal to 1 plus 1/2 m, or m minus 1/2 is equal to the negative value of 1 plus 1/2 m, because in both cases when you take the modulus you will get the same answer in the end. So therefore from this we can see either m minus 1/2 is equal to 1 plus 1/2 m, or m minus 1/2 is equal to the negative value of 1 plus 1/2 m. Now solving these separately, for the left hand side we have m minus 1/2 and 1 plus 1/2 m. Taking this to this side and this to this side, we can see we get m minus 1/2 m, which is 1/2 m, which is equal to 1 plus 1/2, which is 3.5, or 3/2, and we can see dividing both sides by 1/2 we get m equals 3. So one of the two possible values is m equals 3. Now considering the other side, we have m minus 1/2 and minus 1 plus 1/2 m. Taking this other side, we have m minus 1/2 plus 1 plus 1/2 m equals 0. And from this we can see we get 1.5 m, which is going to be 3/2 m, equals, and on the other side we have minus 1/2 and plus 1, which is going to be plus 1/2. Taking the other side is minus 1/2, so we get minus 1/2. And dividing both sides by 3/2, we get m equals negative 1/3. So we get two answers, either m equals 3 or m equals minus 1/3. And these are the two gradients of the two lines L1 and L2. Now here, since we don't know which one is L1 and which one is L2, we get to decide. So I am going to pick this gradient to be the gradient of the line L1 and this gradient to be the gradient of the line L2. Now with that, I'm going to say let L1 be the line with gradient m equals 3, comma, L2 be the line with gradient m equals -1 over 3. Now with this, in order to find the exact values of the equations of L1 and L2, we can again use the fact that both of them pass to the point A, which is 1, 2. So we can use this equation where we substitute in directly y minus y0 equals m times x minus x0. So here, I can just do L1 given by y minus y0, which is 2, equals m, which in the case of L1 is 3 times x minus x0, which is 1. And for L2, I can do L2 given by y minus y0, which is 2, equal m, which is -1/3 times x minus x0, which is 1. And with that, we have found the two equations of L1 and L2. However, I would like to find them in the same form that I gave the line L, which is the form ax plus by plus c equals 0. So here if we simplify, for this one we get L1 given by y minus 2 equals 3x minus 3, and taking these to the other side, we get L1 given by 3x minus y minus 1 equals 0. That's L1. And similarly for L2, L2 is going to be given by actually it's probably easier to multiply both sides by 3 rather than trying to divide by the negative and take the fractions here. So I'm going to divide both sides by -1/3, and then I'm going to get minus 3y minus actually it's going to be plus 6. Minus 2 times minus 1 minus 3 is going to be plus 6. So we get plus 6 equals x minus 1. And then simplifying, we can see we finally get L2 equals x plus 3y minus 7 equals 0. And that is that. We have found the equation of the line L1 and the line L2. So with that, we can finally go into the last part of this question, which says, show that the coordinates of any point on the line L can be written in the form of parametrics of x equals 1 plus 2t and y equals 2 plus t, where t is the parameter and some element of the real numbers. Now for this, we're going to need to go up and take this equation of the line L downward and rearrange it to get what we want. So I'm Control C, I'm going to go down and Control V, put it over here and try and figure out what we want. So here, we basically want the equations x equals 1 plus 2t and y equals 2 plus t. So we want to somehow get these two equations. Now, considering these two equations, if we go down and consider how we could get these two equations from this equation, we can see if you rearrange both of these to get t, from this one we get x minus 1 divided by 2 equals t, and from this one we get y minus 2 equals t. Now from that we can see we need to try to rearrange this thing to get x minus 1 divided by 2 equals y minus 2 equals t. We need to try to get this. Now looking at our equation, we can see how we could get it. We could get it by taking this minus 2 out of the other side and also doing something with this constant. So we can do x plus 3 equals 2y, and to get what we want, we could try to do minus 4 on both sides. So doing so, we can see we get x plus 3 minus 4, which is minus 1, equals 2y minus 4. And now we can see if we divide both sides by 2, we get x minus 1 divided by 2 equal y minus 2. Now with this we can see if we say let x minus 1 over 2 equal y minus 2 equal t, where t is some element of the real numbers, then from this we can get the equations x minus 1 over 2 equals t and also y minus 2 equals t. And from this first one we get x minus 1 equals 2t, from which we can get x equals 1 plus 2t, and similarly we can see over here we can get y equals 2 plus t. So with that we can see we have the two equations that we wanted, the two parametric equations of x equals 1 plus 2t and y equals 2 plus t. So therefore we can say, therefore any coordinate x comma y on the line L can be written as, and then we can write x as 1 plus 2t, comma y as 2 plus t, and we can say where t is some element of the real numbers. And with that, we are done with this part of the question. Now let's move on to the second half of this question. Now at the start of the second half of the question, it says, show also that the equation of the circle C1 that is lying entirely in the first quadrant, having a radius of root 10 over 2, touching both lines L1 and L2 at one point each, and also has its center on the line L, is given by the equation x squared plus y squared minus 6x minus 6y plus 31 over 2 equals 0. So this circle C1 is given by this equation. The question then says, write down the equation of the circle C2 whose ends of a diameter are NB. So basically, find the equation of the circle with AB as a diameter. The question then finally ends on, determine whether the circles C1 and C2 intersect orthogonally. Now to start with this question, we need to find the equation of the circle C1 that has all of these properties and show that equation of circle C1 is this equation right here. Now to start with that, if we consider the information given on circle C1, we can see it has its center on the line L and is touching both L1 and L2. So going down, if we consider the setup of L1, L2 and the line L, copy it down and consider the circle is going to be the circle C1 like this, we can see if the circle C1 is going to be in the first quadrant, it must be somewhere past the coordinate 0, 0. Now since the coordinate 0, 0 is somewhere over here, since this coordinate is 1, 2, we should have a point to the right side of the coordinate 0, 0. So therefore, we're going to have a point that's going to be center of the circle somewhere over here. Now according to that, if we consider, let's say, this point to be the center of our circle, the circle must be a circle that touches both L1 and L2 at single points like this. Now in this case, we can see touches basically means that L1 is tangent to the circle and L2 is also tangent to the circle. Now according to that, we can see the angle from the center of the circle to this point to the line L1 is going to be 90 degrees, and the angle of the other radius to this contact point and the line L2 is also going to be 90 degrees. Now what this means that the perpendicular distance from L1 to this point and L2 to this point are both going to be equal to the radius, which is equal to root 10 over 2. So therefore, if we have the center point here, which I'm going to call, let's say, P dash, the center point P dash must be such that the perpendicular distance from either line L1 or line L2 to P dash is equal to the radius of the circle, which is equal to root 10 over 2. So we're going to write that if the center of C1 is P dash such that, and what we know is that P dash is on the line L, and furthermore L1 and L2 are tangent to C1, then we can say the perpendicular distance from P dash to L1 or L2 is equal to the radius of the circle, which is given as in the question root 10 over 2. So it's equal to root 10 over 2. Now furthermore, since we know that P dash is a point on the line L, and we also know any point on the line L can be given by 1 plus 2t, 2 plus t, where t is summed into the real numbers, we can also say, if this is the first point, we can say a second point that says, since P dash is on L, P dash will be given by 1 plus 2t, comma 2 plus t for some value of t element of the real numbers. And that's going to be equation number 2. Now, as it turns out, we can combine equation number 1 and equation number 2 to find the value of t corresponding to the point P dash that is at the center of the line, of the circle rather, C1. Now, for this, what we need to do is to use the perpendicular distance formula, which says if you have a point h comma k and you have a line which is of the form ax plus by plus c equals 0, then this perpendicular distance d here is going to be equal to the modulus of ah plus bk plus c divided by the square root of a squared plus b squared. So therefore, we can substitute into this formula all of the values that we know here, and we will get an equation in terms of t, which we can then substitute and simplify in order to find the value of t corresponding to this point. So what we can do is to do exactly that, substitute this equation of p into this equation coming from the perpendicular distance of p dash to either L1 or L2, and then simplify to get our equations for t, and then we can see which of those two values of t that we'll get is going to be corresponding to the p dash point that is going to be in the first quadrant for our circle C1 to also be in the first quadrant. So for this, what we're going to do is to consider L1, since I think L1 is a simpler line than L2. So we're going to copy down L1, and then we're going to copy down L1 and say, from this, we get the equation perpendicular distance from L1 to the point P dash, which is going to be equal to modulus of 3 times the x-coordinate of P dash, which is 1 plus 2t, minus, and then y, which is 2 plus t, plus the constant, which is minus 1, so minus 1, divided by a squared plus b squared, which is 3 squared, plus negative 1 squared. So we get 3 squared plus negative 1 squared, and that has to be equal to the square root of 10 over 2. Now, simplifying this down, we can see we get the modulus of 3 plus 6t minus 2 minus t minus 2 minus t minus 1 equal to, and at the bottom here we have 9 plus 1, which is 10, so square root of 10, taking that the other side we have square root of 10 times square root of 10, which is 10, divided by 2, which is 5. So we get square root of 10 squared divided by 2, which is 5. So we get the value of 5. So according to that, we simplify the inside of this modulus, we get 5t, and then actually here it every reason cancels. We have 3 minus 2 minus 1, which is 0. So we get modulus of 5t equals 5. Now according to this, 5t is either equal to 5 or 5t is equal to minus 5. So therefore we get 5t equals 5 or 5t equals minus 5, and therefore t equals 1 or t equals minus 1. Now from these two we get two p dashes, and the first p dash is going to be equal to 2t plus 1, which is 2 times 1 plus 1, comma, and then 2 plus t, which is 2 plus 1, which is the coordinates of p dash being 3, comma 3, which is actually coincidentally the point B. Or we would have the other p dash, which is p dash given t equals negative 1, which is going to be 2 times t, which is 2 times minus 1 plus 1, comma 2 minus 1, which is going to be p dash given by minus 1, comma 1. Now out of these two, this coordinate is in the first quadrant, however this coordinate is not, since it has a minus coordinate. Due to that, since the coordinate of the center point is not in the first quadrant, we can be guaranteed that some part of the circle is also not in the first quadrant, and therefore this coordinate is invalid for the center point of our circle. So we can say invalid as p dash being outside the first quadrant guarantees part of C1 is outside the first quadrant. So with that, we can immediately invalidate p dash equals negative 1 comma 1, and therefore p dash must be equal to the coordinates of 3 comma 3, which is the point B. Now according to this, if we consider p dash being 3 comma 3, we can now find the equation of the circle that is centered at that point having a radius of root 10 over 2. For this, what we can do is use the formula x minus x0 squared plus y minus y0 squared equals r squared. This is the formula for a circle that is center x0 comma y0 and has a radius of r. Now according to that, we can say c dash, or our c1, not c dash, c1, our circle is given by x minus x0, which is 3 squared, plus y minus y0, which is 3 squared, equals radius squared, which is root 10 over 2 squared. Now simplifying this down, we can see we get c1 given by x squared minus 6x plus 9 plus y squared minus 6y plus 9 equals 10 over 4. So this is the equation we get. Now we can see, if we simplify this, we get c1 equals x squared plus y squared minus 6x minus 6y, and then we get plus 18 and minus 10 over 4. So we have 18 times 4 minus 10 divided by 4. Now simplifying this down, we can see we have 40 and another 32, which is 72, minus 10, which is 62, divided by 4, which will be 31 divided by 2. And therefore, the constant term here is 31 divided by 2. So we get finally x squared plus y squared minus 6x minus 6y plus 31 over 2 equals 0. And that is the equation of the circle C1 that we were given in the question. So now we're done with that part. Now we can move on to the second part, which says write down the equation of the circle C2 whose ends of a diameter are A and B. Now for this, we need to know that if you have a circle like so, where the ends of its diameter are 2 points, let's say x1 comma y1 and x2 comma y2, then the circle here, which I'm going to call, let's say C, is given by x minus x1 times x minus x2 plus y minus y1 times y minus y2 equals 0. This is the equation of a circle with x1, y1 and x2, y2 as the two ends of its diameter. So according to that, we can see if the coordinates A, which is given by 1 comma 2, and B, which is given by 3 comma 3, are the endpoints of a diameter of the circle C2, then C2 must be given by x minus x1, which is minus 1, times x minus x2, which is minus 3, plus y minus y1, which is minus 2, times y minus y2, which is minus 3, equals 0. Now simplifying this down, we can see we get the equation C2 given by x squared minus x and then minus 3x, so minus 4x, and then plus 3 plus y squared, and then minus 2y minus 3, which is a total of minus 5y, plus 6 equals 0, which simplifies down to C2 given by x squared plus y squared minus 4x minus 5y plus 9 equals 0. And therefore, this right here is the equation of the circle C2 that has A and B as two endpoints of one of its diameters. Now after that, the question finally says determine whether the circles C1 and C2 intersect orthogonally. Now for this, we need to have the knowledge that if you have two circles in the form x squared plus y squared plus 2gx, let's say 2g1x plus 2f1y plus c1 equals 0, and x squared plus y squared plus 2g2x plus 2f2y plus c2 equals 0, then these two circles will intersect orthogonally if 2 g1 g2 plus 2 f1 f2 is equal to c1 plus c2. So in this case we can see we have two circles in this format. We don't have them exactly because here we can see the 2g is converted into just one constant term. So we have a minus 2, minus 4 here, and for the y and f we have minus 5 instead of plus 2f1. So due to that we need to convert them, but other than that we can directly substitute into this equation and see if both sides are equal to each other. So here what we can do is to consider these two circles which are c1 and c2, consider their f1s and f2s and g1s and g2s and substitute into the formula. So on the left hand side, if we consider the condition, consider the condition of orthogonality, which is 2 g1 g2 plus 2 f1 f2 equals c1 plus c2. On the left hand side, LHS, we have 2 times g1 times g2 plus 2 times f1 times f2, which we have to figure out based on the circles. Now considering g1 and g2, in the first circle we have minus 6x, and in considering g1 we are going to have plus 2g1 times x. So therefore 2g must be equal to minus 6, and therefore g is equal to minus 3. So here instead of g1 we can put minus 3. Now for g2 we have to go up to this circle and we can see we have minus 4 instead of 2g, and therefore g is equal to minus 2. So here we can substitute minus 2. Now for the second circle, so the second part of this equation in the circles, we need to consider f1 and f2. So f1 here in the first circle is minus 6. So 2f is minus 6, and therefore f is equal to minus 3. So we can substitute into here f1 as minus 3. Now considering the second circle f2, we have 2f2 being minus 5, and according to that, if we have 2f2 being minus 5, f2 must be equal to minus 5 over 2. So here we can substitute minus 5 over 2. Now simplifying this, we can see on the left hand side we have 2 times 6, which is 12, plus 2 times 3 times 5 over 2, which if we cancel this 2, we get minus 3 times minus 5, which is plus 15. So we get plus 15 for a total of 17 on the left, or rather 27 on the left hand side. So the left hand side is 27. Now that means the right hand side is 27, our two circles are orthogonal. However, if they are not, it means the circles are not orthogonal. Now considering the right hand side RHS, we need to add the constants c1 and c2. Now going up, the first constant c1 is 31 over 2 and second constant c2 is 9. So if we add them together, we have 31 over 2 plus 9, which is 31 over 2 plus 18 over 2, which is going to be equal to 49 over 2, which is clearly not equal to 27, and therefore our two left hand side, right hand side are not equal, and therefore the two circles are not orthogonal to each other. So with this we can say, if we consider two circles LHS not equal RHS, and therefore C1 and C2 are not orthogonal to each other. Not orthogonal. And with that, we are done with the last part of this question. Now finally, let's go up and from the top, discuss the marks order for this question. So at the start of the question, when you substitute in the formula for the gradient in the line L and get the gradient equals 1/2, you get 5 marks. And then when you substitute the equation of the line L as y minus y0 equals m times x minus x0, you get 5 marks for that. And when you simplify this down to get the form of ax plus by plus c equals 0 and get this equation x minus 2y plus 3 equals 0 for the line L, you get a total of 10 marks for that. Now after that, when you then consider line L1 and L2, which are the lines that have an angle of pi/4 between them and the line L, and then consider the common gradient to be m and derive this equation, tan pi by 4 equals modulus of m minus half divided by 1 plus 1 half m. You get 10 marks for that. And then when you substitute the tan of pi by 4 as equal to 1, simplify down to get this equation, you get 5 marks. And after that, when you then take the two options of either this being equal to this or this being equal to negative value of this and get m equals 3 for one of them and m equals negative 1/3 for one of them, you get 5 marks for each of them. Now after this, when you then go down, take each of these values of m separately and write that L1 is the line with m equals negative 1/3 or m equals 3 as the gradient and vice versa, you get L1 and L2's equations like so. Writing like this or swapping the two and writing L1's equation as this and L2's equation as this gets you 5 marks for each line. Now after that, when you go down and consider the parametric by taking the line L, rearranging it to get this form of x minus 1 over 2 equals y minus 2 equals parameter t, where t is summed into the real numbers, writing like this gets you 5 marks. Now after that, taking this half separately as x minus 1 over 2 equals t and this half separately as y minus 2 equals t and substituting simplifying to get x equals 1 plus 2t and y equals 2 plus t, and then writing that the parametric equation can be written like so, where any point on the line L can be written as 1 plus 2t, 2 plus t, where t is summed into the real numbers, gets you 5 marks. Now after that, when you consider circle C1, consider it to be P dash and write some stuff like this and then go down and use those theorems. When you use the theorem that the perpendicular distance from P dash to L1 or L2 is equal to root 10 over 2 and write down this equation for getting the substitution of the formula of perpendicular distance correctly like this and this correctly, you get a total of 10 marks for the left hand side, and then for writing that perpendicular distance is equal to root 10 over 2, you get 5 marks. So a total of 15 marks for this line. Now after that, when you simplify down to get this simplification here and this simplification here and write this down or write this down as a simplification of modulus of 5t equals 5, you get 5 marks for that. And then when you say that t is equal to 1 or negative 1, you get 5 marks. And from that, when you find the two values of the coordinates at the point P dash, or rather P dash not P, the coordinates of the point P dash as 3, 3 or negative 1, 1, and then you say that negative 1, 1 is invalid for getting to this point, you get 5 marks for P dash equals 3, 3 and 5 marks for P dash equals negative 1, 1 and saying it's not the correct answer. Now after that, when you take P dash equals 3, 3 and from that substitute into this formula to get the equation of the circle C1, you get 5 marks, and when you simplify that to the form of x squared plus y squared plus 2gx plus 2fy plus c equals 0, you get another 5 marks. Now after this, when you then consider the circle C2 that has endpoints of a diameter as A and B, and you consider the equation and directly substitute the equation x minus x0 times x minus x1 plus y minus y0 times y minus y1 equals 0 and get this equation right here, getting that equation directly gets you a total of 10 marks. Now after that, in the last part of the question, when you consider the condition of orthogonality, which is this condition, and substitute the left hand side separately, for substituting correctly, you get 10 marks. And after that, when you find the actual value of LHS as 27 correctly, you get another 5 marks. Now after that, for the right hand side, for substituting and getting the correct answer of 49 over 2, you get 5 marks for the right hand side's value. And then when you say that left hand side not equals right hand side, you get 5 marks because 27 is not equal to 49 over 2. And then finally, when you say that therefore according to this result where left hand side not equals right hand side, C1 and C2 are not orthogonal, you get another 5 marks. And with that, we are done with this question. So I hope you enjoyed. If you have any feedback, post them in the comments down below. Thank you for watching and goodbye.